This is Geometry Lesson 3.8b, Slopes of Parallel and Perpendicular Lines. The objective of this lesson is to relate slope to parallel and perpendicular lines. This is the second half of the 3.8 notes, so this section is just going to focus specifically on our perpendicular lines. So let's jump in. The formal definition of perpendicular lines does not tell us that they are opposite reciprocal slopes. Instead, it focuses on the product of the slopes of perpendicular lines. So I'm going to give you a few examples of some perpendicular line slope pairs, and then give you a second to make a conjecture about them. So one example could be 1/2 and -2. That's a pair of perpendicular slopes. Another example might be 2/3 and -3/2. So think about these two sets of numbers and what their product might be, and then write a conjecture about it. And I'm going to pause the video and ask you. All right, you can check my answers. I actually took them and I multiplied them. When I took 1/2 times -2, I got -1. When I took 2/3 times -3/2, I got -1. So the conjecture that I make is that their product is -1. And if we look down below here in our key concept box, it actually talks about that as well. So if we have two non-vertical lines that are perpendicular, then their product of their slopes is going to be -1. So you can't read that. If the product of two lines have if the slopes of two lines have a product -1, then the lines are perpendicular. Any horizontal line and vertical line are perpendicular. So all horizontal lines and vertical lines are perpendicular. And that kind of goes back to how the numbers behind the slopes for the horizontal and vertical lines, but I'm not really going to get super into that. It's just a fact you should know. So we're going to start by checking for perpendicular lines in a graph. So it says lines L1 and L2 are neither horizontal nor vertical. They say that because if they are just horizontal and vertical, you can just jump ahead and say whether they're perpendicular or not. And so then we're asked, are they perpendicular? And we're asked to explain. So this declaration of perpendicular or not, it comes back to the slopes. So that's the first thing we want to do is get those slopes. Now, like with our parallel lines, you can use your slope formula, or since you have a graph, you can count it out. I prefer the count it out method when I have a graph present. So I do that. Here's my L1. 1, 2, 3, 4, 5, 6. It goes down 6 over 1, 2, 3, 4. I simplify that fraction, I get -3/2. Gonna do the similar thing with L2, so I go from here over to there, and it goes up 1, 2, 3, 4, 5, 6, and it goes over 1, 2, 3, 4, 5, 6, 7, 8, 9. I simplify that and I get 2/3. Now, if I want to check if they're perpendicular, what I technically have to do is I have to take the product of these two things. So I go -3/2 times 2/3. I get -6 over 6, which equals -1. Because their product is -1, they are perpendicular, so I can say yes. You can use the math work up there as your explanation, or you can write out the product of the slopes is -1. And there you have it. So that's how we would do it when we have a graph. This next one, you're not going to have a graph. You're just given the ordered pairs for each of these lines. So what you want to do here is you want to go through and you want to use your slope formula. I'm going to give that to you just in case you don't remember that. It's a good thing to memorize or to put on your geometry note card because a lot of things use it. So there's your slope formula. I'm going to have you pause the video now and decide if line 3 and 4 are perpendicular or not. Here you can see my work to get those slopes. I got -8 and 1/10. I just finished by deciding if they're perpendicular or not, so I take -8 times 1/10. Technically it's a -8 over 1. That makes your multiplication a little bit easier. I multiply the tops, multiply the bottoms, and I get -4/5, which is the same as -0.8, which last time I checked is not -1, so I would say no. You can write out an explanation or you can look it up above. If you write it out, you would say the product of the slopes is not -1. All right, so that's how we just make those decisions about whether or not we have parallel or perpendicular lines. Here it asks us to write an equation of the line that's perpendicular to a line and contains that point. So we did something like this similar with parallel. When I get to a question like this, the first thing I do is I identify the slope I'm using and the point I'm using. Point is always very straightforward. It's just the point that's in the directions. Slope, this is where you have to be careful. Because we want a perpendicular slope, we're not going to take the slope we see there. The slope we see there is 1/5. The slope that's perpendicular to that is the opposite reciprocal. So what that means is we're going to change the sign. So it's positive, our slope will be negative. And then I want the reciprocal. I want to take that fraction and I want to flip it. And that becomes 5/1, which is just -5. So those are the values I'm now going to be using that I now plug into my point slope form. Y minus y1 equals m times the quantity x minus x1. So I plug in those values now. I get y minus the y value, so it becomes +4 equals m -5 times x minus the x value, which is 15. Now sometimes we do ask you to take that and turn it into slope-intercept form. So I'm going to do that now just so we get into the practice of it so you can do it with me. You need to distribute that -5 through. The right side stays the same. I have y plus 4 equals. I get -5x, and then it's -5 times a -15, which is a +75. Now I just finished getting the y alone by moving that 4 over, and I get y equals -5x plus 71. So depending on what they're asking for, your answer could be here in red, or it could be down here in blue. You just have to see if they're asking for a form. If the directions do not ask for a specific form, then stop at the just point slope form, the red up there. Don't spend the time to get it into slope-intercept form. So just be careful when you're doing assignments, tests, or quizzes that you're checking that. Here it says, what is an equation of a line perpendicular to this that contains this point? I'm going to have you pause the video here and try to get this one into point slope form for us. And there you can see my work of getting this into point slope form. I identified the slope of the line I had. I then wrote down the perpendicular slope and the ordered pair and plugged them in. All right, so that's kind of our pretty straightforward method of doing this. We have one more question to do. So it says the baseball field below is on a coordinate grid with home plate at the origin. So home plate is down here. A batter hits a ground ball along the line shown, the player at 110.70. So the player there, that's this guy up here. He's going to run along a path perpendicular to the path of the baseball. What is an equation of the line on which the player runs? So you've got the baseball is following kind of this trajectory. It's going to go somewhere out like that. This guy, he's going to be smart, and he's going to run perpendicular to that route, so he's going to do something along those lines. Now, we can get this more exact by just looking at a few pieces of information. To write the equation of a line, you need two things. You need slope and you need an ordered pair. I know where this guy is located. I already have my ordered pair. I don't have a slope yet though. So what I need to do is figure out the slope of maybe the perpendicular line, the route of the ball, and then I can take that and I can adjust it. So what I would do is maybe count out the slope of this this baseball. So the baseball starts at home plate and then it's going to come, and I see a nice crosshair right there. So I look at that slope. That's going to be up 20 and over 60. I simplify that and I get 1/3. So that's the slope of the baseball, but I want the slope of the runner. The player who's in the outfield out there. So I've got 1/3. I want this to be perpendicular, they said. That means I'm going to take that slope, I'm going to change the sign, so it's positive goes to negative, and I'm going to do the reciprocal. So I'm going to flip it, and I get 3/1. That's -3. So that's what I'm going to use. Now, if you remember your point slope form, I'm just plugging it into that. So that's y minus y1, which is 70, equals m -3 times x minus our x1 value of 110. And that will be the route we would use to model where the player is going to catch the ball. So this was Geometry Lesson 3.8b. The objective of this one, the entire lesson, was to relate slope to parallel and perpendicular lines, and this video was specifically about perpendicular lines.